Anywho, today we're going to work through sheet 3 together. And I'm probably going to do sheet 4 too, even though you're not here. And you get that some other time. Today is going to be all about the cylinder. And we're going to look at that. So sheet 3 is right here. Excuse me. Gonna hurt my throat yelling at you. Jeez. So we're gonna be looking at the cylinder. We're gonna see, what should it be measured at? How worn is it? That sort of thing. We're gonna talk about the top measurement and the largest one, and the unworn measurement. We're gonna talk about cylinder taper. Okay. And then we're gonna measure a bunch of other things here as we go along. Okay. Now, the general gist of it is this. As we come down through the line, we're going to look at the cylinder. We're going to look at the walls of it, see what it looks like. Is it still in good shape? How bad is it? Does it need to be honed out, or does it need to be bored out, or can I just put rings in it? Newsflash, we're not doing anything. We're just putting rings in it. We're not even putting rings in it. We're put the same rings back in. Again, we don't have enough money to completely rebuild an engine all the time. So we're not going to do that. But the things we are going to look at is as follows. So first thing we're going to do is we're going to inspect the cylinder, and I'll show you what that looks like in a few minutes. But we're going to be looking for, there should be, in a perfect new cylinder, you'll see what's called cross-hatching. Okay, so when they bore this engine out, they bore it, and they move the boring tool up and down fast enough that they're not right next to each other, the little scratches that it makes. Kind of microscopic scratches. They're small. You can see them, obviously. You can't really feel them. And then they go the other way. Okay, and the idea with that is that what it's doing is creating these little wall spots on there that will allow oil to get in, and then kind of basically embedded in the wall, and that will then help to improve the sealing with the rings and the piston walls. Okay, that's what's called cross-hatching. Okay, cross-hatching. Okay, now this cylinder we're going to look at here in a second, it's pretty worn to the point where you can't really see any cross-hatching anymore. You're also going to look to see if you see any ginormous, there will always be, after it's been run for a while, like wear lines that are vertical. Okay, those are not cross-hatchings. The vertical lines are not cross-hatchings. That's less than optimal, friends. Think about this. If you put some oil here, it would run straight down, and oil could get past the rings and get up and get burned. Now, that said, in every engine that's been out there running for any length of time, pretty much, there's always going to be a little up and down striations. Now, what we're going to do is run our fingernails across them, crunch, crunch, crunch. If your fingernail catches on those, that is a problem. If you can see them with your eyes, but your fingernails can't tell there's a scratch there, it's not a problem. Okay. If there was, we'd call that scoring. Okay, or in scratching. So scoring is the idea of there's a little bit of these lines here, but it's not that bad. Scratching is when you can actually scratches, or when you can actually feel them. Light scoring, some people will say, well, light scoring, maybe you can just kind of feel it. But okay, the point is, if you can feel it with your fingernail, it's a problem. If you can't feel it with your fingernail, it's not really that big a deal. Okay, so don't want to see that ugly sucker. In here, if you look into there, let me get some light on the subject for you. So if you look, you can see some, maybe you can. You can see some vertical lines, yes? So those vertical lines, the wear patterns in there. See if I can, maybe from underneath. Is that better? Yes. But what you'll notice is I take my fingernail and run across it. I can't feel them at all. Okay, I can see them, but I can't feel them. So this is not bad. Also, toward the very tippity top, the ring, the top ring, you'll notice on the piston does not go to the top. So oftentimes, we call what's called a carbon ring will form right around the top edge of the cylinder here, and over time, actually you'll wear a bit of you will wear down below that top of the piston, because the cylinders will be rubbing on that piston for years and years and years, but it won't be rubbing at the top of it. So sometimes what you'll see is there'll be, for a really worn engine, there'll actually be a ridge at the top, which is where the cylinder should have been, but it's been worn below that to the point to where it's it's very damaged, obviously, at this point. And this one is not like that. This one is smooth as a baby's buttocks, and not dirty either, really. Nice. I don't feel anything with my fingernail. It's nice and smooth. I also don't see, however, any really cross-hatchings in there anymore. I really don't see a total lot of cross-hatchings anymore. I'll try to take a picture of another engine later today, and clip that into this piece right in here somewhere so you can see what cross hatchings look like. Well, maybe I'll just cut a piece from the interwebs and put that in there. Now, what we're going to be doing today is measuring this. As you know, the diameter is the bore. Okay, in the perfect world, this is perfectly circular, and so whether you measure this way, this way, this way, this way, it doesn't make any difference. However, over time, remember the crankshaft runs this way, so this is perpendicular to the crankshaft. When this piston is coming up, and the arm is and the connecting rod is bent over like this, when it's being forced this direction, it's going to be kind of digging into the cylinder wall. That's grossly exaggerated, of course. And then as it comes up toward the top, it's going straight up and down. So on the top, you're going to get full wear all the way 360 on this thing for the most part. Okay. At the bottom, you're going to be getting a lot of digging this way. And what ends up happening is your cylinder becomes out of round, or if you will, a little egg-shaped. Not like this, Mr. Chrome, just a little bit. And so measuring this away is going to be a little bit bigger than measuring this away. Okay, perpendicular will be a little bit bigger than measuring parallel. But you will see that at the bottom and in the middle more so than at the top. Okay, at the top, again, when the piston's toward the top of the stroke, right, and it's obviously like this, you know, that's obviously goes down further than that, all right? But the idea is when it's up that high, the connecting rod is basically straight up and down. But toward the bottom, when it's really kicked over toward canoyers there, you're digging in, and it'll create an out of round scenario for you, okay? Now, so what we're going to do is we're going to do a couple things. We're going to figure out what is this engine supposed to be. Now, if you recall, this is a 10T engine. This manual does not actually cover the 10, well, it kind of does and it kind of doesn't. So it turns out that it's going to be this 10 series engine here. And I know this based on when I went and measured the diameter. If it was these ones, it'd be 2.5 inches in bore, roughly. Okay. Notice that that's plus or minus a thousandth of an inch. Are you with me? So that's the max it could be from the factory is this. Minimum is this guy right here. Okay, that's from the factory. So it'll be within 1/1000th of an inch. Okay. Now, I went and measured it. Turns out we're measuring right in at 2.561-ish. Okay. So as you can see, that's, you know, obviously this one right here. It's the only one, I guess, besides this 13 series, which is not a 13 series. Okay. So it's that guy right there that we're going to use for this. Okay. Now, what am I looking for? Well, what I'm looking for is it will tell me up here. Come on, Shimona. Well, there you go, friends. Look at that. Oh, fart. That's what cross-hatching kind of is supposed to look like. You see that? Okay. But up here, a little bit more. Come on, Betsy. There we go. So what we're going to do, again, we're going to use the telescoping hole gauges, and we're going to measure at the top of the cylinder. We're going to measure perpendicular to the crank and parallel to the crank. We're going to do it in the middle, and we're going to do it at the bottom of the cylinder. Okay, this one should have the most wear, the second most wear, and the least amount of wear at the top. When we're done, the bore is more than 3/1000ths oversized. In other words, if you've been running this engine for a long time and it's worn down and it's more than 3/1000ths over the initial bore amount, it's too big, okay, and that would be a problem. Okay, the rings wouldn't seal anymore, and you're going to have a problem with that. Or it says if you're more than 3/1000ths out of round, that is when you measure, and again, it'll be this bottom one. And when you measure perpendicular to the crank, if it's more than 3/1000ths that way bigger than when you measure parallel, that's an out of round condition. It's egg-shaped, and that's no bueno, senor. No bueno. So I'm going to show you the first measurement here. Then I will probably just stop and do them off camera. It's kind of a giant pain in the tushikins to do this while reaching over. I think I'm going to come around the table this time and do it, if you don't mind. But last time I tried to do it over the top and I kept messing it up, and I finally just started the video over. Screw that. Okay? Now, recall it is imperative that we are perpendicular. Tighten that baby down. Okay, so this measurement here is perpendicular to the crankshaft. Perpendicular to the crankshaft. Sometimes I swear it'd be nice if I had 3 arms. I could find a use for 3 arms most days, I think. What would be nice is to have a clone of myself, I think. Maybe 2 clones. One of me will go fishing, one of me will work. But see, the problem is if I had 2 clones, the one, I would probably, if I was the one, because I would end up being the one that did all the work. Even my clones would be the ones that were out screwing around. That would piss me off. All right, so here we go. So 2.56, 2-ish. I'll try to hold this so you can see it. Oh, fart. It was, yeah, I think I mushed it down there. Anyway, you can see it's 2.5, and then there's 11. So that's 2.55 plus 11. It's 2.561 and a little bit. Are you with me? Okay, so that's pretty good. That's my initial measurement at the top. I'll record the rest of them off camera, and then I'll talk to you about what they are, okay? I don't want to spend your whole day watching Mr. Groom trying to read a micrometer. It's kind of boring. So, top. And that was perpendicular. 2.561. Okay. Now, technically, probably the guy could go down to more the 4th decimal, but I'm not going to be that excited about it, okay? Okay, so there are numbers, friends. As you can see, they're almost identical all the way down. Okay, so what does that mean to me? It means this engine's in really good shape. Am I shocked by that? Not really, on account of what I already said when we looked in there. The cylinder looked great. So we're going to start working our way through the sheet here. This is when the questions will be about. So, to the top here. Refer to the service manual, blah, blah, blah. Record the standard cylinder bore from table 1. That, again, that's 2.6215. 2.5615, sorry. 2.5615. 2.5615 to 2.5625. Those are mins and maxes, okay? That's from the chart. Now you look, you're like, Mr. Grimm, this one is a skosh smaller than that. Oh, I actually went back and remeasured it. It actually came out basically right at it, okay? If you were a couple of 10,000ths off, not a huge deal, okay? That's the answer to question number 1. From what you read under cylinder, calculate the reject size for them below. In other words, when would it be too big? Okay, well, remember, from the factory, it could have come a maximum of this big. If we were 3,000ths bigger than that, where would that put us at? 2.5655. Anything bigger than that, no bueno. If bigger than this is our reject size. Okay, where are we at? How much can you still be out of round and serviceable? Anything less than or equal to 3/1000ths of an inch. Okay. We are smooth as a baby's buttocks. Measure the unworn edge of the unworn side of the cylinder. That's toward the bottom, below where the piston travels. Now, for that, let's see this, friends. I will actually get you back on camera. Can't remember if this is the second time I filmed this or the first time I filmed this that I put this in. But right toward the bottom, you see it's nice and shiny right there. That's the piston doesn't come down that far. The rings don't come that far anyway. So I'm going to go ahead and measure all the way at the bottom. In theory, whatever we bored the cylinder with at the factory, whatever they bored it with at the factory will be it should have been perfectly circular at the factory, in theory, right? Oh, fart. Try it again. And so the unworn portion at the bottom will tell us what it came from the factory with. Oh, you hippie, you're not staying. Well, I hate you too. Piece of crap. I don't really hate it, Mr. Groom. Mr. Groom, you shouldn't say things like that, I feel like. I was reading like on face pages. Oh, nice job, dummy. I was talking to myself. I'll interrupt myself with myself. My story from earlier. I would like to clone myself. I think that'd be fun. Not because I really like myself that much, but I usually get a lot of work done. So it would be nice to have someone who worked as hard as I do to get some work done with me. 2.561 2.5617 it looks like. So our unworn 2.5617 is what it looks like. Now you come over here, Mr. Groom. How is this one smaller? And how is this one smaller? It's off by 2/10,000, and Mr. Groom probably made a little boo-boo reading it. Okay, so not a huge deal. So that's our unworn measurement. Cool. Is it a standard size or is it overboard? Well, how would I know, Mr. Groom? Well, standard size is between 2.5615 and 2.5625. Are we between there? Yep. Then we are a standard size. Also, it's a good bet on an engine that was made whenever this one was made. You know, well into the 21st century, if you will. People don't really bore these things anymore. If this thing had been made in the 60s, yeah, it's a good bet that it could have been bored at some point. Someone might have done some work to it. Okay, but as new as this engine is, no one has worked on these things like that for a long time. Okay, now here we go. What we are going to do is we are going to find what is called the amount of cylinder taper by measuring the cylinder at several places in the top ½ inch where the wear is greatest. Okay, so in the top cylinder. Okay, in the top. Okay, so we're going to subtract those. We're going to figure it out. Okay, now. When we do this, we're finding a cylinder taper. Okay. Now, with it, I don't really like the way that's worded, but what we're going to do is this: we're going to find our biggest measurement pieces here. Okay. We're going to find our biggest differences, and so our biggest one is, I guess, this guy here. Minus our unworn size. What did I say? 7? 7. So your taper is 5/10,000, right, or less than a half a thousandth, which means we're in golden in terms of our shape here. Okay, so just be aware of that. So we're going to determine our out of round by measuring. The large measurement is one of your answers there. So obviously, what we want to do is measure the biggest differences here that you see. So our biggest differences are. This is 7/10,000s rather. No, it's not. It's 5/10,000s. And this one here is also 5/10,000s. And this one here is 2/10,000s. So when you look at this worksheet over here, you're asking yourself, well, the difference between them is out of round. Well, we're at 2/10,000s. Okay, well, how does that make us look? It makes us look really good, right? Because clearly, what just happened? Oh, I can't write. Oh, cancel. Fiddle faddle on you, sir. Fiddle faddle, I say. So, anywho, there you go. So, 2/10,000s. Okay. So, the question is this thing ready to re-ring or does it require boring? Okay, well, it would require boring if it was out of round beyond the maximum, or if it was worn, it was worn beyond that. If it was up here, if we had too big a cylinder taper, if we were or if it was out of round, those would be the reasons we'd have to bore it. It's not. So in theory, you pull a piston out, you're going to put new rings on it, okay, if you're really, really building a car. That is not what we're going to do with this rig. We're just going to put it back together and run it, okay? So ready to re-ring is what we're looking for here, okay? Now, these are some questions I will probably have on this, but if you think about it, if your cylinder is out of round, well, last I looked, your piston is round, and your rings are round. So if the cylinder was egg-shaped, like a thou, you know, it's a little over-exaggerated, what would happen to your rings? And then, because if your rings have an issue, what else is going to happen? Think about that. And, oh, fart. And what happens to the cylinder taper, same kind of process. Anything that's going to be wrong with your cylinder is going to affect your rings. And if your rings are bothered, the same things are going to happen every single time. Go back and think about what we've looked at. You know, what do the rings do? They help create something, and they also keep something where it belongs, okay? So those are the things to be looking out for on this guy here. Very, very healthy engine.